Many people wouldn't think of diving near an arid desert. But these divers have discovered that this lake, like many other inland bodies of water throughout the world, offers underwater adventure and fun. It's a great place to practice and learn underwater navigation. When you're skilled in underwater navigation, you reduce your stress and relax more because you always know where you are and where you're going. You avoid long, tiring swims on the surface. And you plan your dives more effectively because you can swim directly to your objective. Underwater navigation helps you and your buddies stay together and saves air because you take the shortest route from one point to the next. And your navigation skills are the foundation for learning search and recovery. Learning to navigate underwater is like learning to ride a bicycle. It's a bit of a challenge at first, but with practice and the help of your PADI instructor, you'll learn quickly. Before you know it, navigation will be second nature. It's a satisfying feeling to complete an intricate underwater pattern right on the money. And it's fun. Underwater navigation consists of 6 basic skills. The first is distance estimation, so you know how far you've swum. By applying natural navigation skills, you maintain your orientation by observing your surroundings. Compass navigation gives you the greatest precision possible. In many instances, underwater patterns simplify navigation. And dive site relocation allows you to return to a dive site on the surface. Finally, using navigation aids can make navigating easier and more precise. To navigate underwater, you need to know 2 things: the direction you swim and the distance you swim. We'll look at direction in a moment, but now let's look at 5 methods for estimating distances underwater: kick cycles, elapsed time, tank pressure, arm spans, and measured line or tape. Probably the most convenient way to measure distance is to count kick cycles. A kick cycle is 1 kick for both legs. To track kick cycles, choose either leg and count each time that leg returns to the same position in the fin stroke. Swim a known distance, such as along a measured line, at a relaxed pace, counting kick cycles. Then divide the kick cycles into the distance. The result is how far you travel in 1 kick cycle. If you cover 100 feet 30 meters in 20 kick cycles, you know you travel 5 feet 1.5 meters per kick cycle. When you first measure your kick cycles, you may find that you get a different number when you swim the same distance more than once. Make several runs to get an average. Maintain neutral buoyancy and swim at a steady but unhurried rate. With practice, you'll even be able to stop and start again without affecting accuracy much. Keep in mind, however, that changes in your equipment, such as your fins, exposure suit, or BCD, may change the distance you travel in 1 kick cycle. Water motion, such as currents, also affects kick cycles. In low visibility, you usually slow down to avoid running into things. You can also estimate distance by timing yourself and determining how many feet or meters per second you swim. Timing can be more convenient than kick cycles because you don't have to count, but you can't stop during your swim. If you take 100 seconds to travel 100 feet 30 meters, you know you cover about 1 foot, 0.3 meters per second. You may find it easier to track it as 10 feet 3 meters each 10 seconds. As with kick cycles, consistent, steady swimming gives you the most accuracy, but changes in your equipment may change how far you swim per second. Estimating distances with your tank pressure is especially useful when following a pattern. Divide the pattern segments into your pressure and change direction based on your air use. Keep in mind that depth variations, water movement, changes in exertion level like rapid swimming, and delays affect how much air you use for the same distance. Generally, tank pressure is less precise than kick cycles or timed swims. Use arm spans to measure short distances accurately. You'll find this especially useful in low visibility. Vertical arm spans are fastest. Horizontal arm spans are slower, but a bit more accurate. Using a tape measure or marked line is slow and can be difficult with an irregular bottom or obstacles. But for navigation that requires high accuracy, such as precision mapping, you can't beat a pre-measured line or tape. Whether you know it or not, you already have experience with natural navigation. Natural navigation is determining your direction and location by observing your surroundings. Heightening your conscious attention to the navigation clues around you will improve your natural navigation. Natural navigation begins with pre-dive observations. By noting natural indicators before the dive, you'll have navigation references during the dive. Note the direction of wind, waves, current, or tides if present. Locate offshore rocks, reef lines, or shallow areas. Check the direction of sun and shadows and which way the sun will move relative to your dive site. Ask divers experienced with the area about objects or structures and note their location. This can help you pinpoint your position while diving. When diving from a boat, a depth finder can show you the bottom profile and depth to expect. Your sense of direction plays an important part in natural navigation. It often helps to begin your descent with one buddy facing the direction you plan to go and descend head up. When you reach the bottom, your sense of direction will be oriented to your initial direction. Try to form a mental picture of where you are in relation to the boat or shore. During your dive, natural references will help you navigate. Although water diffuses sunlight, you can usually make out the sun's direction from shadows. If not, try to find it by looking at the surface. Pay attention to the bottom. Places where the bottom changes, from rock or coral to sand, for example, may form natural lines you can follow. Sand ripples lie parallel to shore. Swim perpendicular to them toward shallow water, and you're usually headed toward shore. The bottom contour can also help you find your way. In some environments, navigation is as simple as following the natural contour. Don't limit your observations to what you see. Chains clanking, rocks or shells tossing in the surf, or loud motors can help you navigate. Although it's hard to tell a sound's direction underwater, the loudness can help you tell how close you are. Different dive sites may have differing navigation clues. Water motion, such as waves, currents, or surge, can provide an underwater reference. Just keep in mind that these can stop or change direction during the dive. Some plants and animals grow only in particular places. For example, sea fans typically grow at right angles to the prevailing current, and freshwater plants are usually larger and more abundant towards shallower water. Becoming familiar with such organisms provides another means for finding your way. Pay attention to large features which can give clues to your whereabouts. And track changes in depth, which can alert you to your position. Wrecks frequently provide distinct lines you can follow out and back. In your open water diver course, you practice compass use at the surface and underwater. As you may recall, compass use allows you to follow a heading with no other reference. When combined with distance estimation, a compass makes it possible for you to map the site and locate your exit underwater, even over a featureless bottom or in limited visibility. With practice, you'll be able to swim to an object more than 100 feet 30 meters away and arrive within a few feet or meters of it. Let's begin with the features to look for in an underwater compass. Most compasses for diving are liquid-filled, so they withstand pressure and to make the needle move smoothly. Look for a compass needle that turns even when the compass isn't quite level. If you wear it on your arm, a low profile makes getting in and out of your equipment easier. You'll want a compass with numbered degree markings, and you'll find glow-in-the-dark features useful in low light. A compass should also have a lubber line or direct sight to show your travel direction. A lubber line is a fixed reference line, usually through the center. With a direct sight compass, you read your heading from the side. Electronic compasses use digital and liquid crystal displays to provide compass features in an electronic instrument. Now let's review the basics of compass use. A compass works because its magnetic needle is attracted to the north magnetic pole. The needle always points north, giving you a constant direction reference. Using a compass begins with learning how to hold it. First, hold the compass as level as possible. This allows the needle to swing freely. Next, align the lubber line with the center line of your body. Keep it aligned as you swim. This is important because if it's off-center, you'll be well off your intended direction. If you wear your compass on your wrist, lock your arms like this. Or hold it like this if you hold it in your hands. This position works well for console-mounted compasses. Now you're ready to set the compass heading. Face the direction you want to go with the lubber line centered with your body. Turn the bezel until the index marks bracket the needle. It helps to remember that the needle always points north, and the lubber line is always your travel direction, regardless of where the bezel's set. Swim with the compass level, keeping the lubber line aligned with the center of your body. Look over rather than down on the compass. Notice that how you set the compass for a specific degree heading depends on your compass. If the numbers don't move when you turn the bezel, you have an indirect reading compass. If they do, you have a direct reading compass. To set an indirect reading compass, turn the bezel to set the index marks at the desired degree heading. Then keep the lubber line centered with your body and turn until the needle is within the index marks. To set a direct reading compass, turn the bezel until the desired degree heading rests at the point of the lubber line. Then turn until the needle is within the index marks. As you can see, although you read both types differently, the same heading points you in the same direction. A reciprocal heading reverses your course. Simply turn the bezel to set the index marks on the opposite side of the compass. Turn until the needle is within the index marks and you're facing the direction you came from. In mastering compass navigation, keep these hints in mind. First, trust your compass. Remember, it's more likely that you're disoriented than that the compass is wrong. Combine your natural navigation skills with compass use. This enhances your accuracy. From time to time, brush up on your compass skills and practice on land before diving. Take currents into account if you dive in one as you navigate. When navigating in mid-water, have your buddy monitor depth while you follow your compass. Maintaining neutral buoyancy is important. In clear water, use point-to-point navigation. Pick out an object ahead along your compass bearing and swim to it. When you get there, use your compass to pick out another object to swim to. Continue until you reach your destination. This is easier than watching your compass as you swim. When navigating to a specific point over a relatively long distance, intentionally navigate to one side of your destination. That way you'll know which way to search if you miss. If you're swimming perpendicular to a current, aim for a point slightly up current to compensate for its effect. Finally, be patient and realistic. You and your buddy should swim slowly, relaxed, and deliberately. Take your time and keep in mind that underwater navigation has its limits. It's most useful in a relatively limited area. At many dive sites, you'll find it easiest to navigate by using underwater patterns. Patterns apply your navigation skills to a predetermined course. The simplest pattern is to go out and back on a straight line. With a compass, you simply swim out on one heading and return on the reciprocal heading. This can be restrictive, but it works well when you can follow a long, narrow formation, such as the side of a reef. You'll find squares and rectangles very useful patterns. They cover large areas, and they're based on 3 90-degree turns, which you can even make accurately without a compass. To change your heading 90 degrees with a compass, swim until you reach the turn point. Stop, then reset the bezel 90 degrees. Add 90 degrees for a right turn or subtract 90 degrees for a left turn. Turn until the needle is within the index marks and resume swimming. You'll also find that swimming 3 sides of a square or rectangle is a good way to navigate around an obstacle. Triangles require a compass. You may find this a handy pattern in a restricted area. Navigate a triangle as you would a square, except make 2 120-degree turns instead of 3 90-degree turns. U-patterns are great for underwater searches. Swim a long distance, turn right 90 degrees, and swim a short length about half as far as you can see. Turn right 90 degrees again and swim the long side, followed by a left, the short length, left again, and so on. It's difficult to properly navigate a circle without a rope. Circle patterns are mainly for underwater searches, not navigation. You can learn more about circle patterns and searches in the PADI Search and Recovery Diver course. To make navigation more effective, be sure to discuss the pattern you'll use with your buddy. Try to visualize the pattern, or even draw it, so that it's clear in mind during your dive. Keep patterns small and don't hurry. It's easier to stay together if one buddy navigates and the other follows. Use the pattern as a general guide. As you deviate slightly from the pattern, keep the general heading and direction in mind. Except on deeper dives, if necessary and conditions allow, surface periodically to check your bearings. One of the most useful skills you can learn is dive site relocation. It allows you to find a specific spot from the surface. This saves air and time because you don't waste time searching underwater. And it can increase safety by avoiding direct descents into unfamiliar areas. Dive site relocation is also a rewarding skill. It's exhilarating to descend right onto a dive site you can't see from the surface. It's a mark of a diver who's mastered navigation. Begin on the bottom when you've found a site you'd like to return to. Note the depth, bottom composition, and topography to record in your log. Ascend, staying directly over the dive site. In currents, an anchored line makes staying over the site much easier. Fix your location as soon as you surface. You do this by establishing two bearings that intersect with your position. You can do this without or with your compass. Without your compass, pick out two or more permanent landmarks that line up exactly. Tall, thin landmarks like trees, poles, water towers, smokestacks, and building edges are ideal. One should be close, and the other as far away as possible. Next, turn 60 to 120 degrees and do the same. Note the landmarks and lines to transfer to your logbook for future reference. A compass lets you take a fix without aligned landmarks. Find a prominent landmark and point the lubber line at it. Set the index marks over the compass needle and note the degree heading. Turn 60 to 120 degrees and do the same with another landmark. Jot down the headings for your dive log. To relocate your dive site from the surface, swim or motor until your landmarks or compass bearings line up exactly as you recorded them. This should put you over or very close to your site. Descend directly to the bottom. If you're not on the site, search the immediate area. If you don't find the site, you may want to ascend and realign your fix. Navigational aids make navigating easier and more effective. A compass board extends the lubber line, making it easier to align with your body. This enhances accuracy. Two tools can help you with navigation: a course plotter, which lets you chart an irregular course, and a heading calculator, which tells you the headings for legs in a pattern. The Nav Finder combines both a course plotter and heading calculator into a single tool. To plot a course with the Nav Finder or other course plotter, all you have to do is keep up with your compass headings and swimming distances. Features of the Nav Finder include north arrow, compass heading arrow, initial heading window, compass ring, grid, and center of course plotter. You plot your course beginning at the center. For example, suppose you begin heading 90 degrees. Rotate the compass ring until 90 degrees lines up with the compass heading arrow, also the north arrow. Begin traveling on that heading. After 12 kick cycles, you decide to turn. Assuming you use a scale of 1 grid square per kick cycle, you would draw a line 12 grid squares long straight up from the center. Your new direction is a heading of 180 degrees. You set 180 on the Nav Finder and your compass and begin swimming along your new heading. After 8 kick cycles, you stop and draw a line 8 grid squares long, straight up from the end of the last line. Your next heading, you decide, is 265 degrees. You set 265 on the Nav Finder and your compass and swim on that heading. After 5 kick cycles, you stop. Now you draw a line 5 grid squares long straight up from the end of the last line. Note that you always draw toward the top. You can record as many course changes as you want in this manner. To return to where you started, put the end of the last line directly under the center. The heading on the nav finder is now your compass heading back, and the grid shows you the approximate distance. In this example, the shortest route to your starting point is 323 degrees for 11 kick cycles. The nav finder also simplifies navigating patterns. Set your present compass heading, and the calculator shows you the appropriate headings for 90-degree turns and reciprocal courses. This is especially useful for navigating squares, rectangles, and U search patterns. For example, suppose your heading is 20 degrees and you want to swim a counterclockwise square. First, set the heading calculator at 20 degrees. Next, follow the counterclockwise arrows as marked to find your next heading, 290. So, you would swim the first side of the square on a 20-degree heading, then the next side on a 290-degree heading. The next would be 200. And finally, 110 degrees on the last side. With practice, you'll find the Nav Finder a versatile tool that helps make navigating easier and more accurate. Electronic navigation equipment makes dive site relocation a snap. Loran and GPS instruments pinpoint your location based on radio signals. This eliminates landmark fixes. Loran uses land-based signals, and GPS uses satellite-based signals. GPS equipment costs more, but it's very accurate. Loran has less accuracy, but costs less. Underwater navigation helps you save air, time, and energy. Mastering navigation is a bit of a challenge, but it's rewarding and fun. Of course, the guidance of a PADI instructor in a PADI Advanced Open Water Program or Underwater Navigator Specialty Program makes mastering navigation skills faster and more effective. These courses take you through the basic navigation skills, including distance estimation with kick cycles, elapsed time, tank pressure, arm spans, and a measured tape or line. By applying natural navigation, you maintain your orientation by following a course based on pre-dive observations, light direction, bottom composition and contour, and other environmental clues. By mastering compass navigation, you learn to hold the compass, set headings, reciprocal headings, and swim a compass course. Underwater patterns apply your navigation skills to a predetermined course, such as out and back lines, rectangles, and triangles. Dive site relocation saves you time and conserves air. You want to be able to fix and return to a site based on inline landmarks or compass bearings. Finally, navigational aids make navigation more accurate, more flexible, and more convenient. Underwater navigation means you know where you've been, where you are, and where you're going. And that is one of the greatest satisfactions in diving.